Hello, welcome back to Learn Physics. In today's topic, we are continuing with our mechanical properties of fluids. Okay, so in last class we were discussing about the applications of Bernoulli's principle. Today also in the coming portions we are discussing about the applications of Bernoulli's principle only. Okay, so here first we are going to discuss about heart attack. So here how the heart attack happens. Usually we will say if cholesterol is high or pressure variation is there, then heart attack will happen, isn't it? Yes. The reason is, blood will be pumping through the tube to the heart, isn't it? Artery. Here plaques will be accumulating, or fat. We will say fat or plaque will be accumulating over here. When it is accumulating over here, what will happen? Blood can't flow easily to the heart. Okay, so the heart should supply or should give more pressure to suck the blood. Okay, so heart should give more pressure. So that means it will be coming with a high velocity, because here it is plaques are more, so the flow is not proper and it is very less flow over there, and because size is less, we know as A into B is a constant as per equation of continuity, isn't it? If area is decreasing, what will happen? Velocity will increase, isn't it? This is as per equation of continuity we already learned. So when it becomes, a constriction will be there at in the tube. So what will happen? This here blood will be, while blood is flowing through this, what will happen? Velocity is more. But we know as per Bernoulli's principle, half P plus half rho V square is a constant, plus rho GH is a constant. H we are not considering, since it is, we are not considering the height over here. P plus half rho V square is constant. If V is increasing, what will happen to the pressure? Pressure will decrease. So what will happen to the outside pressure? Outside pressure is more. Okay, so again it will, outside pressure is more and inside pressure is less. What will happen? Then again it will be collapsing. Then what will happen? Again it will be increasing the pressure and will be many times it will be happening. Velocity is increasing, pressure will decrease, outside pressure is more. So by the continuous application of the same thing, what will happen? Heart will be collapsing, or we can say heart attack will happen. Okay, this is the reason, the physical reason behind heart attack. Okay, so the plaques in the tube will be accumulating and it make a constriction in the tube. Okay, so what will happen? The heart should work hard to get the blood inside, and the blood which is coming inside will be of high velocity. Okay, as velocity is increasing, what will happen? Pressure will decrease, but outside the pressure will remain the same. Due to the variation of pressure, this variation of pressure, what will happen? Heart attack will happen. Now you understood, right? Pressure also equally important, and this accumulation of fat also equally important in the case of heart attacks. Okay, so next one is dynamic lift. That is the second one. Dynamic lift. What is meant by this dynamic lift? So while we are throwing some object in the air, this we will explain mainly for the air. Okay, gases only we will be considering that this dynamic lift mainly. Okay, so through air, when suppose we are throwing a ball, so some amount of air also will be dragging along with that, isn't it? But if while we are throwing the ball, in two ways we can throw the ball. One is without spin and other one is with the spin. Okay, in both the ways, what is the difference between these two? In without spin means the ball will be moving like this and the air molecules or gas above and below will be moving with the same velocity. It will be having the as a terminal flow, or it will be having a constant flow through like this. Okay, so it is a layer only it will be moving. Okay, so it is no variation in velocity or pressure over here. Variation of velocity or pressure won't be here in this case of if the ball is moving without spin. Okay, but if the ball is moving with the spin, what will happen? A part of air also will be dragging along with it when we are when we are throwing the ball with a spin. Okay, with the spin, if the ball is throwing, a part of air along with it also will be dragging along with it. So what will happen? In that way, while we are doing, air just above will be accumulating at this side and below won't be happening the same way. Velocity will be less over there. Here what will happen? Velocity of air will become more, and here velocity of air below will be less. As velocity of is more, what will happen? Pressure will decrease. If velocity is less means pressure will increase. What is the reason? Here we explained. Isn't it? So as per our Bernoulli's principle, as velocity decreases, pressure will increase. While pressure is increasing and here pressure is decreasing, what will happen? From higher region to lower region it will move. Isn't it? So it will be, there will be a force in the upward direction. So this force is called as dynamic lift. Okay, so if we are moving, usually in cricket and all we will say spinners. Spinners means they will be throwing ball with the spinning. That means what is the use of that kind of spinning? So usually we know projectile means it will be a parabolic path. But in the case if the man is throwing with the spin, we can't predict. It won't be continuing in the parabolic path because it depends on the dynamic lift, and the velocity of the spinning also it depends, isn't it? So the velocity of the air above the ball is decreasing and increasing, and below the ball is decreasing. As velocity is increasing, pressure will decrease, and velocity is decreasing, pressure will increase. Okay, so this upward lift is called as dynamic lift. Clear? So if ball is moving with the spin and without spin, so all these are also examples or applications of our Bernoulli's principle. Okay, so another one is aerofoil. Aerofoil means it will be an instrument like this. Here also same thing will happen. When it is throwing, when we are throwing that one, air above it will be accumulating over here. So velocity is increasing and pressure will be decreasing. Below this, velocity will be decreasing and pressure will be increasing. The same way we can explain this aerofoil also. Example of aerofoil is the same phenomena, only we are using in aeroplanes. The wings of the aeroplanes also of the shape of this aerofoil. So what will happen? So there will be an upward force acting on the aeroplane to lift it upwards. Okay, so when it is moving, it will be helping it to balance it over there. Okay, while we are considering, and the engine, while we are moving with some particular velocity and all, they will consider this uplift also, or dynamic lift also. So the reason is the velocity is when the ball is moving with the spin, what will happen? Some of the air molecules near to it also dragging along with it. While it is dragging along with it, what will happen? The air above the ball will be accumulating over there and velocity will be increasing, and that will cause a decrease in pressure because of Bernoulli's principle, and then Due to Bernoulli's principle, we know as velocity is increasing, pressure will decrease, isn't it? So, but below it, pressure will increase since the velocity is less. So, because of this difference in pressure, an upward force will be acting on the ball, and which will be varying that, which will make a variation in the trajectory, that is parabolic path. It won't continue in its parabolic path. Okay, clear this heart attack and dynamic lift? Next we are going to study about the next term, that is viscosity. Viscosity. What is meant by viscosity? See, we learned about the resistance in electricity, resistance is there, and while we are in mechanics also, resistive force, friction and all we learned, isn't it? Here in the case of fluids also, when one flows over the other, frictional force will be, or resistive force will be acting between them. Okay, that is called as viscosity. Okay, so when the one layer moves over the other, when the fluids are flowing, what will happen? A viscous force will be acting between them. What is that viscous force? Viscous force means the resistive force between the each layer of fluids. That is called a viscosity. Okay, so it is the property by virtue of which when one layer of fluid moves over the other. So if we are considering water or alcohol, or it is diesel, petrol and honey, all oil, all these fluids, while we are considering water, and water will be moving very fast, isn't it? It's we are suppose water falling down, it will spread very easily, isn't it? What about honey? It will be very slowly, will be yes, it is sticky. Then we know it is resistive forces more for that, isn't it? And oil also, compared to the honey, it is moving faster, but not that much faster like water, isn't it? So viscous force means it is the resistive force between the different layers of fluids, that is called a viscosity. Okay, so now we are going to study about the viscosity. How we can find out this viscous force? Viscous force, how we can find out? Okay, in the case of fluids, so stress acting on the fluid will be proportional to strain rate. Okay, in the case of fluid, rate means with respect to time. So stress acting on the fluid will be directly proportional to the strain rate. Okay, so stress is proportional to strain rate. Rate means strain divided by time. Okay, now we are going to find out this proportionality. Stress is proportional to strain. What is the meaning of that? It will be, so if we are drawing a stress is proportional to strain, means we know it is a proportionality, means it will be a straight line, isn't it? Stress and strain are proportional. In stress strain curve, I taught you that one, isn't it? So stress is proportional to strain, and so it will be a straight line graph, isn't it? Stress means force acting per unit area. Strain is the change in dimension to the original dimension. Here, while we are considering change in dimension to the original dimension to the time, with respect to time we should consider. Okay, stress is proportional to strain. That means as stress increases, strain also will increase. Stress decreases, strain also will decrease. Okay, why I explain now stress strain once more is, one of the viewers asked me, how can you explain once more the stress strain curve? So the whole thing explanation will be difficult, because after finishing the portions I'll repeat while I am giving the revisions and all. Revision time I'll explain. So for the time being, you understand like this. Stress is proportional to strain means it is as stress increases, strain also will be increasing. As stress decreasing, strain also will be decreasing. If we are drawing a graph between stress and strain, we will be getting a straight line graph with a slope. Okay, so now coming back to viscosity. Okay, so I am considering a fluid, a part of fluid, that is A, B, C, D. Here fluid, it is moving as layer like this. Okay, so I am considering this part. Let L be the length. When it is flowing like this, in a time interval delta t, okay, it is making a distance of delta x. Okay, in time interval delta t, it is giving a difference of delta x. So this end is reaching to this side C dash, B dash. BC reached to the position B dash C dash, and still we can consider this D over here only. It was ABCD like this. Now the new position is A, B dash, C dash, D in an interval of time delta t. Delta x is the displacement happened. Delta x is the displacement happened. Now, as per this equation, stress is force by area is proportional to strain rate. What is the strain? That is shearing strain. Shearing strain is, what is shearing strain? Tan theta. How we can find out tan theta? Opposite side divided by adjacent side. Delta x by L. Rate divided by time. Okay, so this is strain, that is tan theta divided by time. Okay, so F by A is proportional to, what is delta x by delta t? That is velocity, V by L. Okay, so what is F by A is proportional to V by L. This proportionality sign we can change by multiplying it with a constant eta. Eta is called a coefficient of viscosity. Okay, or we will say viscous force also we will say as eta into V by L. So what is eta? Eta is equal to FL by AV. This is coefficient of viscosity. Okay, clear? So in a fluid, we are considering a small portion of the fluid. In that, in a delta t time interval, the upper layer is moved to a distance of delta x. Okay, so stress is proportional to strain delta x by L. How we got that? We considered this tan theta because it is shearing strain, only upper layer is moving. So delta x by delta t we can consider it as V by L. So it is eta is equal to FL by AV. From here we can find out the unit. What is the unit of coefficient of viscosity? Unit of eta, how we can find out? What is the unit of force? Newton meter divided by meter square, meter second to the meter per second. So we can write like this. So we will get it as Newton meter to the power minus 2 second. Okay, Newton second meter to the power minus 2, or we can write it as Poiseuille. Poiseuille is the unit of PI, viscosity, eta. Okay, eta is Poiseuille is another unit of viscosity. Or another unit is, what is F by A? Is F by A unit is Pascal, pressure. Isn't it? And L by V. Now you tell me, meter divided by meter per second, or we can write it as Pascal second. That also, and meter by second. So taking the reciprocal and multiplying second by meter, you will get meter and meter will get cancelled, Pascal second. So unit of eta is Newton meter to the power minus 2 second, or Pascal second, or Poiseuille. These are the units of coefficient of viscosity. Now can we find out the dimension? Dimension of eta, how we can find out? F unit, this dimension is m L t to the power minus 2. L is L. A is L square. V is L t to the power minus 1. So L will get cancelled. Here 1L will get cancelled. T to the power minus 1 while and t to the power minus 2. From here now it will become minus 1. So m t to the power minus 1 L to the power minus 1. This will be the dimension of eta. See, simply, no need to go all those things by heart for by hearting and all. See here, just by heart the formulas and how we are obtaining stress is proportional to strain rate. That proportionality constant is called a coefficient of viscosity. So FL by AB, that one you remember. So in the case of, while we are considering the fluids, that is liquids and gases. As temperature increases, what will happen to viscosity? Viscosity will decrease in the case of liquid and viscosity will increase in the case of gases. As temperature increases, viscosity will be decreasing. Okay, viscosity, as temperature increases, it will be moving faster. As temperature increases, viscosity will be increasing in the case of gases. Okay, so but in the case of blood, 0 to 37 degrees Celsius, till 37 degrees Celsius, viscosity will be remaining the same. Okay, so understood all of you? So I am winding up for today. If you like the channel, please don't forget to subscribe. Thank you for watching. Bye.